My name is Andrew, and well, this is I'm going to talk about how I worked managing build and integration infrastructure of Debian derivative. So first of all, some bits about myself. I started contributing to Debian in 2007. Some years later, in 2013, I became a Debian developer. And 2 years later, I started working for Collabora, a company which does open source consultancy, basically, and sponsored this conference. So I only started doing actual packaging in 2010, and it was basically, it started as a joke. A friend of mine claimed you cannot package something for Debian in half an hour, and I tried to prove him wrong. Well, I didn't manage to package that package in half an hour, but still I've got into, well, Debian packaging. I never attempted to run any bits of real Debian infrastructure. I've only used minid install to publish binary packages for my users to test. So I barely know how to properly manage real Debian infrastructure. But then I started working on a project in Collabora called Apertis. This is a Debian derivative, which is tailored to automotive needs. And basically, originally it was developed to run on infotainment systems, basically machines which do the navigation and play radio for you. But it is in fact fit for quite a wide variety of electronic devices in automotive area. So this project, it provides quite a lot of infrastructure for code hosting. It provides its own code review tools, package build services, image generation services, and also automatic testing infrastructure. And well, even though it is a Debian derivative, it is based mostly on Ubuntu, not directly on Debian. Even though it takes several packages directly from Debian, for example, systemd. And on top of all of that, it provides a set of its own software frameworks, packages, and APIs for automotive needs. So we, as I mentioned, we use systemd for process tracking. We heavily use AppArmor to enforce policies on applications. And even, well, we take AppArmor from Ubuntu, but we extend it with policies for lots of applications already on Ubuntu and Debian, and also to our own applications and packages. We use Flatpak, thanks to Simon McVitie, for safe and efficient deployments of applications in there. We use Wayland for graphics, so there's no more Xorg since, I think, last year. And, well, obviously we use GStreamer for multimedia. So, well, some people may say, why do we use Ubuntu and some bits of Debian and not just Debian? Which is, well, a universal operating system, and it is entirely free software, and it is being developed by a community of individuals and not companies, which often happens. Well, all of those things are great, but unfortunately, stable moves a bit too slowly for us. And once it's released, the changes to stable are minimal, and it quickly becomes very outdated. And then when the new release is out, the changes are often quite significant. On the other hand, unstable breaks a bit too often for us to base on it. Whereas Ubuntu, they do releases more often, and even in LTS they push up updates more often, and it moves slightly faster than Debian stable, and even then they have quite a large install base, so they have lots of testing. Yeah. So now a bit about infrastructure we have in Apertis. So the core of this infrastructure is Open Build Service, OBS, which is thanks to unreleased package for Debian, by the way. So we store Apertis-specific sources in Git, and at the moment we use Git, but there is a plan to use GitLab for this. From Git, Apertis-specific sources go into OBS, where the rest of packages are stored. Mostly it's packages from Ubuntu and from Debian, which go there directly or with some modifications. OBS builds binary packages, and they go into apt-compatible package repositories. Then they get installed into images, which can be used directly on the devices. We use Jenkins to manage image builds and other continuous integration paths, and we heavily rely on Fabricator for project management and backtracking. And we also use Lava for testing the actual images on actual devices. So something about Open Build Service. Just like as built, OBS uses its own code to create chroots in which the package is being built in a clean, well-defined environment. So OBS resolves dependencies every time from scratch and installs build dependencies and builds the package. It stores all packages in a revision-controlled manner, so you can see how the package has evolved. You can check out any older version. If it's needed, revert and build it again. And actually, it resembles Subversion in many ways, this package storage. It provides access control. So basically, for every project, every package, you can choose whether it is accessible for reading, writing, and so on. Packages may have maintainer role assigned to them, so one user can manage it in manage this package similar to what we have in Debian, and even if a user doesn't have right access to a certain package, there's a branching feature. So a user can clone the package into his own sandbox, develop the package there, and then submit a merge request. So even non-maintainers can contribute changes and test them. And well, this branching feature it very much also resembles the Subversion branching and merging because it is based on directory-like namespaces. So in OBS, Apertis is split into multiple components. Unlike Debian, there's no main, contrib, and non-free. The split is done differently. Every component is in its own OBS project. So the component split is target, development, HMI, SDK, and snapshots. And there's also helper libs. So target are packages which are getting installed on the device itself. Development are mostly additional packages which are needed to build what's in target. SDK are tools which are needed only for development, and they are installed into special SDK images, where users can also install additional packages from helper libs. HMI is a special component with software for human-machine interface packages, which is what is used for infotainment systems. And finally, snapshots is a special component which is used to store and build development versions of packages right from the Git. So in OBS, you can specify dependencies between components. So when packages from one of the components are built, they may depend on packages from other components. So, for example, development uses target. Well, actually, it's other way around. It's well, in fact, development can use packages from target, but target uses packages from development to be built. And SDK depends on development. So you can select multiple components when you on the live system, but the SDK sort of assumes you have also development and target. When OBS builds a package, it is getting published into internal OBS repositories, which are normally you have just one per project. Those repositories are not in apt format, so we use repo to make them accessible to apt. Those internal repositories are used by OBS to build other packages within the same project. So when a package is being built and published into this repository, it can be used as a build dependency for other packages in the same project. And this makes it very easy to do full rebuilds. You just add an additional repository, which is not published into apt repositories, which depends on the main repository. So packages can be rebuilt, and the results of the build can be discarded. So it's easy to detect detect situations when some packages stopped building after some time because of changes in their dependencies or in build order or for some other reasons. Right. So to work with packages, we've developed a number of workflows which are different for packages imported from Ubuntu and Debian and for our own packages. So, well, packages from Ubuntu and Debian to which we don't do any changes at all, they are imported to OBS either manually or using OBS feature. Basically, you can copy packages from elsewhere. If the changes to the packages are quite minimal, which happens often, we just commit changes directly in OBS, keeping patches in deb3 format, and well, all of those modified versions, they have a prefix similar to what Ubuntu does. But instead of Ubuntu 1, Ubuntu 3, we put CO1, CO2, and so on. And we also use the fork of Ubuntu's merge-o-matic tool called merge-ao-misc to pull new updates from Ubuntu LTS. So it can handle simple merges and automatically rebase our changes on top of what Ubuntu has. And certain packages are kept in Git to make the merges easier. And then in Git, we use both Debian standards and our own approach. So for non-Apertis packages, we use deb14. We keep upstream code in upstream branches and Apertis specific branches for packaging for Apertis packaging. And when we release a new version of a package, we add an Apertis version tag. And we use git build package and its gbp pq command to manage patches. But for native Apertis packages, we use slightly different approach. So we don't keep Debian packaging and the source code separate. We keep both on master branch, When we create a new release, to be able to push updates for the previous released distribution, we create a release specific branch on which we put changes specific only to that release. And we use two sets of tags, Apertis specific tags for changes specific to the packaging, and just the version tags to releases of the upstream code. So a normal upstream release is usually two tags, one just version number, and the other is Apertis version number CO1. And if later on we need to do some changes in packaging only, we just add Debian packaging tags. And if we change the actual code or apply patches, we bump the upstream version number. So we have a Jenkins instance which every time something is committed to Git, it picks the top commit of a branch and builds it in a controlled environment, which is not the same as OBS. This environment is updated, at the moment it is updated manually from time to time when the build dependency change. Because we use this approach because we didn't want potential unrelated build failures to cause failures to build our code. Well, if, for example, Bash becomes uninstallable, we don't want our code to fail to build because of that. So when the build succeeds, Jenkins generates a source package which is submitted to OBS and is committed to the snapshot component. OBS builds the package once again in a clean root, and if the build succeeds and it was a release, which means it was tagged as a release, it submits a merge request on OBS to the component from which the package originally came. Jenkins uses a build snapshot script written by Simon. Mostly, this script has been used to to build packages and to create source packages for uploads to the OBS. This script is probably going to get packaged for Debian as well, because it is useful not only for Apertis, and it has many other uses, but so far it's not yet been submitted. We also have CI procedure for new patches which are submitted at Fabricator. So before they are being reviewed by actual humans, Jenkins applies them to the top of the branch and builds them in the same environment. And if the build fails, the submitter can immediately see that there's something wrong and they need to change the code. And that's basically about packaging. Now, image builds. Also controlled by Jenkins. The same Jenkins instance as is used for packages and the rest. We use Lenovo image tools, which build images in a multi-stage process in which we separate hardware-specific components of hardware-independent components. If there's someone familiar with how linear image tools work, basically this means that, first of all, we have something called OS packs and hardware packs. So OS pack is basically part of the root file system with packages which are specific to this architecture, but not this specific device. So they can be shared by multiple devices running on the same architecture. For example, MX6Q Sabrelite and Raspberry Pi. And the hardware pack is also part of root file system where device-specific files are installed, like firmware or device-specific U-boot or maybe device-specific kernel. and they get combined, producing a set of images based on this architecture for every device. So we create multiple OS packs for different types of images. It is, well, as you can see on this slide, it's at least target and development. There's also SDK image and a number of other images. Since we support 3 architectures at the moment, which is AMD64, ARM64, and 32-bit ARM HF, we produce quite a lot of them. So image build process builds hardware packs and OS packs, and then combines them into actual images, which can be run on the devices. Generates sysroots for the SDK. SDK is based at the moment on Eclipse, and it allows users, developers, develop applications in a more user-friendly way. So they need sysroots of the system for this. So after sysroots are built, Jenkins triggers test on the Lava image, or the Lava instance, so the images are installed onto the devices and being tested and verify that they actually boot and do something useful. In fact, we use auto package test infrastructure for not only this infrastructure, but we also use it for certain packages. And then a special job scans the package change logs in the image and closes the bugs which are fixed by new package versions. So there are lots of challenges in maintaining all of that without and using something else than standard Debian infrastructure. I'm going to start from the bottom because, first of all, OBS isn't quite like S-built, and it builds packages in a slightly different way, which often doesn't matter. But at times, there's some difference which makes some packages to fail to build from source. At the same time, the same packages build quite fine in Debian. One of such differences is that OBS ignores essential flag, and it needs manual overrides to specify which packages are needed to be pre-installed before any build dependencies are installed. Sometimes we mess up those, and packages fail to build in very funny and interesting ways. Next thing which is sometimes difficult is that Merge-O-Matic can handle simple package merges when changes do not conflict with each other. But when they do, it fails, and it forces the user to, or the maintainer to resolve conflicts manually. And this is quite difficult because it doesn't provide any meaningful conflict description, or it provides something to start with, but it's quite difficult. Using Git helps because Git can solve many of the conflicts Mom can't, but then you can put the whole distribution into Git. Well, you can, but it's quite difficult, and we don't have many packages in Git. It's about a couple of dozens packages which we maintain. Packages from Debian and Ubuntu with our own changes, but we can't put everything there. And then when packages are removed from Debian or Ubuntu, it's a bit difficult to keep track of packages removed and remove them in Apertis as well. As I mentioned previously, we plan to provide GitLab to make it easier for potential contributors to contribute, because at the moment it's just a cgit instance, and it's not easy to it's not easy for contributors to create their own forks of packages, do work, then submit it back. They need to go through all official ways of contributing. There's now a work in progress to automate the release creation because it involves quite a lot of manual work, updating packages, creating new branches, and this is something I'm going to automate. And there's also work in progress to stop using linear image tools because they are quite difficult to maintain. They sometimes fail in part because of specific bugs in Linux kernel, which are very difficult to trace and fix. So now we have a custom tool which is much simpler and handles image creation much better. Basically we're going to shift focus to become a common platform for more automotive systems, not just infotainment as it was until now, so that Apertis can be used for a wide range of devices. And basically, this is it. If you are interested in Apertis, there's the web page. You can go and learn more about it. And, this is it. Questions? Answers? Proposals?
Have you considered using that testing as a middle ground between stable and unstable?
Sorry?
Have you considered using testing as a sort of rolling release between stable and unstable?
Well, testing is better than unstable, definitely. But, well, first of all, the decision wasn't mine to use Ubuntu. But I can see certain challenges in using testing as well, because, well, it's, in many ways it's basically unstable delayed slightly. So still changes, things change there quite often and quite a lot. We need something more stable than testing, but more lively than stable.
Fair enough.
If I can expand on that a bit. For a while, we were using non-LTS Ubuntu. So it was updating like every 6 months. And we decided that was essentially spending too much time rebasing. It was too much of a moving target. And we weren't getting enough benefit from the more frequent updates to justify it. So we dropped down to using only the LTS releases.
Yeah, that's another reason. Rebasing to new releases, and well, not even new releases, just pulling updates from the same release within its support cycle is quite a lot of work. And with testing, it would be quite a constant work which needs to be done and doesn't often bring benefits.
Beautiful thing. Hi.
Hi.
So I'm working on Ubuntu sometimes. I'm interested in some of the things. You want me to stand up? Oh, sorry. I didn't know you were trying to film me. So it sounds like you do most of your testing on the images that you produce, not on the packages, like the individual package uploads. Is that right?
Sorry?
Most of the testing you do is based on the actual like produced image product rather than the packages on the packaging level. Wondering if you've thought about using something like Brittany and/or like running auto-package tests on the packages as you upload them, or if you've ever done that before. So, as a bit of history, in Ubuntu we introduced these like maybe 4 years ago or so, and so previous to that, developers would just upload their stuff straight into the development release. You know, kind of like we still have in Unstable in Debian now, right? And you get problems with like arch skew or just like random broken packages or like half-done transitions making it through to your, you know, essentially the product you're trying to give to your users. For us, the development release for you, like maybe you get broken images from this from time to time if you have transitions half-done. Wondering if you ever thought about like introducing more of the kind of Debian like testing like release management stuff into your workflow.
Well, we first of all, we also run the package test, Debian rules test basically, and since we've done integration of auto package test into our test infrastructure recently, we can technically run tests for the whole already existing tests in other packages which come from Ubuntu and Debian. And there was a plan to do that, but it's just we basically need to somehow separate those tests from the rest of what we have, so that it's just quite a lot of work to deal with failures which happen due to changes which were introduced in Ubuntu or Debian. Right. So yeah, there were plans to do this. I think it's been implemented, but we haven't switched it on.
Right. So we do this in Ubuntu. When we introduced this, we started redirecting uploads to a new suite. So sort of like...
Sorry?
We started redirecting uploads to a new suite in Ubuntu. That's what we call them. So instead of developers uploading directly to the development release, their uploads are automatically redirected to a staging area. Mm-hmm. And then we have Brittany sort of running, and only once Brittany thinks the packages are good enough, are they then copied into the thing that we build the release from. Mm-hmm. So, I mean, for you, that would be like when somebody uploads to an OBS, you'd upload it into some other area, and then you would, when the automated tests are passed, you would then migrate them into another repository, which is the one that you build your product from. And
right, so if someone fails the test, it doesn't get into the production.
It's just held there, yeah, and then you can see the results, and then somebody has to fix it before it makes it through to the place you build the products from. I don't know if that's interesting to you, but for us, I mean, I feel like it's given us a lot more confidence in the things that we're producing.
Oh yeah.
Especially in the presence of tests, like at least we know that they've gone green, or somebody has looked at them and overridden them. It's just interesting.
Okay.
Okay. Anybody else want the mic?
If I can just respond to that point, we had. So we started running more. We started running more auto package tests and things like that for the stuff we pull in from Debian and Ubuntu. But the problem with that is not all test failures are equal. We have a lot of packages in the distribution that some of them, if they fail, it's like, well, now the product is broken. And some of them, if the tests fail, it's like, well, do we even care? We're using like 1% of this package. If the test failure is in the other 99%, it's really not even worth our time to identify it, let alone fix it. So we have to be quite we have to be quite careful about making sure that we only test things that we would even want to fix, and that we don't waste developer time on debugging things that don't actually have a significant impact.
Oh yeah, I personally spent quite a lot of time trying to figure out why certain packages failed. Well, there are some build dependencies of packages we use, but basically they are part of SDK image only. Those were basically packages written in Java, and some of them would randomly fail because of test failures. So after spending quite a lot of time in figuring out why the tests failed, and they failed because, well, one of the packages started failing because it is suddenly 2017, and the package was designed to, well, it was not designed to fail in 2017, but they never thought it will live that long, and some test was not expecting the new Unix time or something like this. So sometimes disabling tests in some leaf packages helps, in fact. Yeah, because we don't need to test all of the packages which are just build dependencies for something we don't use all the time.
If we had enough developer time to make all the tests for all the packages pass, it would be amazing.
Yeah.
But we just don't. So we have to prioritize.
So anything else? Okay, thank you then. Thanks for coming. And that's it.